Hello and welcome to What is Programming lecture. I just want to cover with you what are some of the basic things about programming, how does programming work, because this will go hand in hand and dovetail into the assignments and the learning plans and things to get you started. Now, programming, basically it's making something that's dumb smart. Let's think about this for a second. When you look at your PC or your Mac or whatever program, or your tablet, whatever your computer you're using, that computer really isn't all that smart if you think about it. If you take the programming out of that computer, all it is some material, plastics and things like that. The only thing that makes it do what it does is programming. So we're taking something that isn't very intelligent and putting intelligence to it. We're creating the brain for it. And a lot of things that we do, we need to have logic and math. We're going to go through some logic exercises when we talk about flowcharts, but we need to understand and anticipate what are our users' needs, what's the computer going to do, how does this program need to work. Let's go through some math, because you use math a lot in various programs. Now, it's usually not complicated math. It's usually the basic add, subtract, divide, multiply, that sort of thing, maybe rounding type stuff, but most of the math is pretty basic. But you usually need to have some math. And basically, how do we take and build something to where our computer does stuff for us and works for us? Now, there's several tools that we're going to use throughout the semester. Google, JSLint, and JSHint. We're actually probably going to use JSHint more than JSLint. That's a tool to make your program as elegant as possible. It goes through syntax errors and fixes things up for you. JSFiddle, I'll show you that tool as well. It's a tool for having HTML, CSS, and JavaScript kind of work together, and it's kind of like a playground type of thing. And with that being said, I mean, we're going to spend a lot of time in the JavaScript world, but we're going to touch a little bit on HTML and CSS. Not a whole bunch, but if you want to be a quality developer, you got to know it's a three-legged stool, as I refer to it: HTML, CSS, and JavaScript together. W3schools.com is a good resource for learning and tutorials. So is Code Academy. Code Avengers, we're actually going to use them for some assignments, so you'll get very familiar with them. Browsers, I recommend either Chrome or Firefox. If you're on a Mac, of course, you could use Safari and Chrome and Firefox for that matter. But I don't usually recommend Internet Explorer because it likes to do things its own way. With each release of Internet Explorer, it's getting better, but it's still not to the level that Chrome and Firefox and stuff are. And then there's inspection tools that allow us to look at our code through our browser. And we're going to use these. I'll show you how to use these as we go through like the debugging section and things. And how do we, as we're running our program, if it's not running the way we want it to, how do we figure out why? How do we do that? Tools that are called inspection tools, like Firebug, or there's built-in native inspection tools built into Chrome and Firefox, or the Web Developer Toolbar, and there's others. How do we use those tools to debug our code to figure out what it's doing and figure out where the problem may lie? So I'll show you that. We'll use those tools. If you use Chrome or Firefox, you have inspectors already built into those. So we'll show you how to use those. And then editors. Now we're going to use Visual Studio. Editors are sometimes called IDEs, which stands for Integrated Development Environment. Really, to do JavaScript, all you need is a notepad to do it. I don't recommend that, or you'll go cross-eyed, but you just need a text editor. You're going to see me using Visual Studio. The reason we use Visual Studio is because it kind of goes hand in hand with in LP1, which many of you are probably taking at the same time. You're going to be doing C#, and Visual Studio is the C# editor. So rather than have you have to learn a different tool, we thought it would be good to just have you learn the same tool, because you can do this stuff in there. Doesn't mean you can't use Dreamweaver and Notepad++. There's no one called Brackets. There's one called CoffeeScript, if I recall correctly. There's another one called Adobe Edge, if you're an Adobe CC subscriber. So there's a bunch of them out there. If you just Google IDEs, you'll find them. Eclipse is another one, that's for Java. So there's a bunch of them, but you'll see me using Visual Studio for the most part. Now let me show you a couple of these things in my browser here. So let me bring up my browser. And one of the first things I want to show you is some of the sites that you have available to you. If you notice, one of the things I said was, of course, Google. I highly recommend it. I mean, all of us have Googled subjects at one point or another, but if you're running into problems, there's a lot of resources out there to help. So Google it, see if you can figure out what the issue is. Another one, JSLint and JSHint. Those are two what are called code quality tools. So here's JSLint, which is a code quality tool. You put your code in there, click the button, and it tells you where you have errors and problems, and you can set up your parameters and the options down here. Feel free to use this. I'm actually going to, you'll see me use one called JSHint, which is built on top of JSLint, but I like the interface personally a little more. You put your code here on the left, and it tells you on the right what are some issues you have in it. For example, if I get rid of my semicolon, it tells me, hey, on line 13, I'm missing a semicolon. So I put the semicolon, it goes back. So I use this one quite a bit. There's another one called JSFiddle. And so what you can do is you can come in here, you put HTML in this box, CSS in this box, or JavaScript in this box, and the result shows up over here on the right. So you can even have it do JSHint for you, kind of hooks into that. You can load JavaScript libraries. We won't use this a ton, but I want to let you know it's out there, because once you get more proficient in JavaScript, this becomes a pretty cool tool to use to work with your JavaScript and HTML and CSS all in kind of one screen. It's basically like a light IDE, so to speak. And then these three, W3 Schools, Code Academy, and Code Avengers, let me show you those. So W3 Schools has a lot of tutorials, excellent tutorials. You can come in, you can learn JavaScript, you can learn CSS, HTML, and others. There's a bunch of them out here, so feel free to take advantage of that. Then there's Code Academy. This is another way to learn programming. Now a lot of these, it says, you know, here for free. A lot of these, the way they work is they give you so many for free, and then you have to pay for like the upper levels of that. So if you want to continue on, you can do that. But this is one. We're going to be using one called Code Avengers, and you're going to actually do the first 40 lessons. So you would come in and you would do the first 40 lessons, not in HTML and CSS, but in this JavaScript. It's a free trial, and so you get the first 40 lessons for you. Okay, so feel free to peruse that, and we'll get you set up and going on that, because you'll have assignments based on that. And there's a bunch of other sites like code.org and things where it can help you out, and you can learn to code. So there's a bunch of ways. This is opening a door for you in a bunch of different ways on how you can get better. I mentioned browsers. You're seeing me use Chrome. You can use Firefox and things. But let me talk to you a little bit about an inspection tool. And I'm going to use NTC's site for an example. So if I want to take a look at these, if I want to click, I can go into Tools and then go Developer Tools, and it opens this down here. This is the inspector tool. Now I'm not going to go into great detail yet. When we get to the debugging section, I'll go into great detail on this. But what this allows you to do is I'm now looking at the code, and as you can see, some things are highlighted on my screen. If I have any errors, like here's an error that we have on it, I can fix that. So there's a bunch of stuff that you can do with these inspectors. So that's one way to open it. You can also right click and click Inspect Element. Both Firefox and Chrome work the same way, where you can go into the tools, to the menu, or inspect the element, and you can see how that brings up that inspector. We'll use that quite often. And then in the editors, we're going to use Visual Studio. So if you don't already have it, you're going to want to make sure you have an editor like Visual Studio to get it set up and use, and so that you can do your programming and do your assignments. Like I said before, we're going to be using JavaScript to teach you programming concepts. Now, notice the name of this course is not Introduction to JavaScript, it's Introduction to Programming. There's a reason why. The focus of this course is to learn programming concepts. We're going to use JavaScript to teach you that. We're kind of killing two birds with one stone. You're going to come out of this class understanding programming concepts and having a solid base of JavaScript. And that way, because JavaScript you find everywhere. You find JavaScript, of course, on websites. You find JavaScript in mobile devices. You find JavaScript in desktop applications. All over the place you find JavaScript. There's even a way you can build a web server using JavaScript. So that's a very good language to learn. But we want you to learn these programming concepts, so no matter what language you want to learn, because there's thousands of languages out there. There's some of the main ones, but there are literally thousands. You can learn those concepts and those nuances because you have the basics of it. If I want to learn a new language, I understand that language's work. It's just learning the nuances of that particular language. We're also going to teach OOP principles in this course, not procedural. Procedural is an old way to do it. We're going to teach OOP principles. And then we're also going to go through debugging. There's actually a debugging learning plan we're going to go through. I'm going to teach you how to use that inspector, and so that you can inspect your code and look at it. We're going to learn about breakpoints. What a breakpoint is you tell it, run my code, and when you get to this certain spot, take a break, stop until I tell you to go forward. We're going to use alerts. Alerts are pop-up messages to the end user so we can see how things are working. And then we're going to do stuff both in our browser and in the IDEs such as Visual Studio. And then last but certainly not least is comments. I've mentioned this before. I will harp and harp and harp on comments. Put comments in your code so you understand what's happening. There are reserved words. This is just a sampling of them. You'll see them in the learning plan as well. Basically what reserved words are words that you cannot use in your code like of variables and stuff because they're used for other purposes. They mean something. For example, the word function defines a JavaScript function. So if you create a variable and call your variable function, you're going to run into some problems with that. So there are times when you want to stay away from certain words that are used as keywords in that particular language that have special meaning. There are some, because I mentioned before that JavaScript is a loosely typed language, so it doesn't have the strictness of other languages. There are some that aren't really reserved words, but you want to stay away from them. Like alert is actually used to pop up. It's a method within JavaScript to pop up a message to the end user. There are times you could use words like that throughout your code and it wouldn't run into errors, but you want to stay away from them. That way you don't have any possibility of doing that. Okay, I want to talk about OOP versus procedural. So there are certain terms that we're going to use that I want to make sure you understand, and I'll let you, I'm not going to read the slide, I'll let you take a look at that, but you'll hear me use the words like class, object, methods, properties, parameters. You'll hear me use those terms, so I want to make sure you have an understanding of the definitions of those terms. Now, I want to describe a little bit in more detail about class and object. I'm going to go through an example that talks about that and methods. Basically, class is a blueprint, and object is what you create from that blueprint, and methods are what that object can do based upon the blueprint details. Okay. Inheritance is another one where you can inherit what one class does or one object does to another class. And so if I create, if I have an animal class, you'll be going through animals in OOP1. If I have an animal class and my animal, all my animals can give birth, then any object I create off of that can give birth, and I can cascade that down to the children of that. So it's called inheritance. You'll learn about that more and more as we go through. But let me go through an example that might outline this in greater detail, these concepts about classes and objects and things like that. So imagine we work for a company that makes cars and trucks. And our cars have colors and engine sizes and transmission types and number of doors and things. So we might have a class that's a car class that specifies how colors are done, engine sizes are determined, transmission types, number of doors on a car, things like that. Same thing with trucks. So we have these blueprints that tells us how we're going to build those. Now, in a production environment, if we're building a ton of cars, we're not going to create new blueprints for each car. We create our blueprint once, and then we create a bunch of cars off of that. Like subdivisions, we create one blueprint for a house, we build a bunch of houses off of those blueprints. You don't recreate the blueprints every time. So that's what a class does. A class is a blueprint, and then you create an object off of that class using that blueprint. So that blueprint, that class, tells the object how to act and how it works. and how the specifications of it and the methods and properties and all that stuff. So you create your class once and you can create many objects off that class. So that's called the object is sometimes referred to as an instance of a class. It's an object instance, or it's an instantiation of that. So imagine here that we have that. Now we do have some things that you might notice. If I have cars and trucks, I actually have some commonalities here. We have both cars and trucks have colors, they both have engine sizes, they both have transmission types. There are some differences: cab size, number of doors, towing capacity. So in a procedural environment, we create code for each one of these. Each truck's color, each car's color, each truck's engine size, each car's engine size. We can use object-oriented programming principles to set things up in such a way it saves us from that redundancy. So in procedural programming, we'd have to write the code first, process the car form, and then the code for the truck form. With OOP, we can create a base class. Let's call it vehicle class. And in that vehicle class, we have whatever methods we have. And so we have color, engine size, transmission type. So that vehicle class has those three. Those were the commonalities between our trucks and cars. So then we can use something like inheritance. And just as a side note, there's times when you don't want to use inheritance. But in this case, let's use inheritance, where we can say, okay, all of our cars and all of our trucks are going to have colors, engines, transmission types. So here we would create a car class, and our method in our car class is number of doors. If you recall, we had in the cars color, engine, transmission, number of doors. We pulled color, engine, transmission into its own vehicle class, so the car class inherits everything from the vehicle class, so we just had to add number of doors. Same thing with truck class. We had to add cab and towing capacity to that. Now, where the rubber really hits the road is as you are making changes and working with your code. So let's say that your boss comes to you in this factory and says, hey, we want to start manufacturing and selling buses. Well, in a procedural world, we would have to create code for the color, engine size, transmission type, and number of passengers. Let's say those are the items for our bus. So we'd have to recreate everything, the form, all the code, and all that stuff. Now, we may be able to save some time with copy and paste, but still, we'd have to recreate everything. With OOP, all we'd have to do is extend that vehicle class just like we did for cars and trucks, and then add in the methods and the properties or what have you that don't exist for cars and trucks, that only exist for buses. In this case, number of passengers. Now, there's also times where the logic may change. So let's say that you previously stored color in your database and now your client wants it emailed to them, or vice versa. Well, in a procedural world, you'd have to change that in your cars, all your trucks, all your buses. In OOP, all you have to do is change it in your vehicle class, because your car, truck, and bus classes all extend or inherit from that vehicle class. So you have one spot to change it, and the others will take that through inheritance, take that change along with them. Now, let's say here's another scenario for you. Your boss comes to you and says, you know what, we've been making these generic cars, trucks, buses. We want to start moving into some specifics. We're going to make specific makes. We're going to make Nissan and Mazdas. So if you are a procedural programmer, you now have to go through all the coding for a Nissan and Mazda, just like you did for car, truck, bus, and add specific information for each make. In the OOP scenario, what we would have to do is we'd have to extend the car class. So you have your vehicle class. That gets extended to the car class, so the car is inheriting from vehicle. Then you can create your Nissan class, which is inheriting from the car class, and Mazda class, which is inheriting from the car class. And then we just put whatever unique methods or programming in those classes that Nissan and Mazda take. So it allows us to do things much simpler, segment things, create this hierarchy so we understand how the program is flowing. Now, none of us are ever going to program a bug, right? Unfortunately, the bugs are a necessary evil, I guess. Sometimes we find bugs because we're human and we make mistakes. So let's say we find a bug in a transmission type area. Well, procedurally, we would have to go through each spot where we do that. The cars, the trucks, the buses, the Nissan, the Mazdas, and we would have to update each form, each code, and all that. in OOP, all we would have to do is fix the transmission type method in the vehicle class, and that change then gets, through inheritance, goes to every other subclass underneath it as it's extended. So it's much easier to maintain and keep your programming in a logical, concise, easy, maintainable fashion. So let's go back to our learning plan, and we'll take a look at how we do some of these things and how we work with this code. This is just to give you an introduction to principles related to OOP and programming. Don't worry if you don't quite understand something. As we get our hands dirty with some things and get tactile with learning our programming and learning JavaScript, these things will start to make sense as we go through. Thanks, and happy coding.